Okay. Yeah, welcome everyone. Very happy that we have a full room, even at this faraway location, considered like it's far away from town, right? For me, it's not so far because I live in Tampines, so it was a very quick cab ride over here. So today I will show you a little bit of what I've learned about, ChatGPT, large language models, and GitHub Copilot, and another AI model called Whisper. And how you can use these things to really power charge your Python development. So you will learn a bit about AI stuff, and you will learn a little bit about Python development as well. I will show you in real time how to build a little Python program, very useful one from scratch. Okay. So I'm actually a member of the Python user group society in Singapore, and this society was founded 12 years ago or so in order to make it easier to organize PyCon so that we have a bank account and we can receive sponsorship money and all that. So I've been one of the main organizers of the annual Python conference here in Singapore for about 6 years or 8 years or so. And we also have a new website now, pax.org.sg. It's a little bit like, one of those email subscribing things where you can, subscribe for free, and then every month or so, once or twice per month, we will send a little newsletter about things that we have done in Singapore and upcoming other interesting talks about Python that you might want to be aware of. Yeah? So you can consider subscribing to that. It's free. And I guess most of you here probably heard about this via Eventbrite and whatever material the library puts out. But if you want to follow more Python-specific talks in the future, you can go to meetup.com and search for a Singapore Python user group. And we try to have at least one meetup every month where I try to get 2 speakers into a room, and then there will be some free pizza usually, and you can just come in. It's very friendly, very nice, and listen to 2 experts talk about interesting stuff about what they do with Python in their work. It's a very good way to pick up new vocabulary, to pick up new workflows, pick up new ideas, and also do a little bit of networking. There are usually companies that hire, right? Or if you are hiring, there are usually very talented people that are looking for jobs and so on. It's a quite nice little community. Really quickly about myself. So my name is Martin, and usually I say you can interrupt me at any time, but last time I gave this talk, it turned out to be exactly 1.5 hours. So maybe don't interrupt me. I will try to get to the end of the talk as fast as I can, and then you can ask many, many questions, okay? I came to Singapore 12 years ago. I am currently the CTO of a company called theartling.com. We are a large online art gallery, curated contemporary art. I'm also a committee member of the Python user group, as I have mentioned. And if you want to follow me on Twitter, I usually post about Bitcoin, nutrition, React, and Python, specifically Django stuff, because building websites with Django is kind of my day job. You may consider following me on Twitter. So let's get into the actual talk. GPT-4, right, is the thing that's everywhere in the news now and seemingly is changing the world at a very rapid pace. So let's start from the very beginning. What does GPT even stand for? It means Generative Pre-trained Transformer, okay? It's a so-called large language model. So LLM is a term that you might want to use if you do some Google searches and you want to search for other large language models, of which there are many now. And it's also a so-called multimodal large language model, which means it has several modalities. You can't just input text. You can also input images, which is currently not really possible on the ChatGPT platform that many of you might have used. Unless you are paying and you have access to the Pro account, then I think you might be able to upload images, but I haven't actually played around with that myself yet. But theoretically, it can accept text, images, and in the future, probably also audio. So there are several modalities that you can put in, and then it will understand these things, which is quite amazing. And it has a context window of 8,000 tokens, or if you pay more money and it's going to be slower, 32,000 tokens. And I will explain later in detail what this means. That is a very important metric if you deal with these large language models. I guess you always want to have as many tokens as you can. Like, there's one model out there, I forgot the name, that has 100,000 tokens already, but it's not as smart as ChatGPT. But yeah, I mean, some of these models already try to push the boundaries and get even larger context windows. And it was released very recently, right? So this whole AI craze basically started on March 14th when ChatGPT became available, and then people started talking to it, and they realized, man, this thing really gives astounding replies. The CEO of OpenAI, Sam Altman, said that it has cost $100 million just to train this model. And there are rumors that this model has 1 trillion parameters. We will see on the next slide what this might mean. So this GPT family didn't just pop out of nowhere. It feels like it just popped out in March and now the world isn't the same anymore, but this has been coming a long time already. The paper that started it all, the Transformers paper, came out in 2017. I will show that on the next slide as well. And then in 2018, they built the first model around that. And you can see the first model had 117 million parameters. I will explain in a second what that means. And a year later, they made a better version with already 10 times more parameters, 1.5 billion parameters. And then another year later, they made another version with 100 times more parameters, 175 billion parameters. And now this version that everybody is talking about, ChatGPT 4, they don't disclose anymore exactly how it works internally. So we don't exactly know how many parameters it has. But yeah, there are rumors that it might have 1 trillion parameters. I mean, if you extrapolate from how this has grown over the years, it seems reasonable that it might be 1 trillion, right? And here we can see these models, they basically get to read an unbelievable amount of text, of, hopefully high quality text. And you can see also, this also grows by a factor of 10, basically, from each evolution of the model, right? So we also don't know how much text has been used to train GPT-4, but I don't know, I would guess a few terabytes, most likely, right? So basically, this text is going to be like all of Wikipedia, scientific papers, gigantic libraries of books that have been scanned, and all these things like that are considered high-quality sources of information. And large parts of the internet as well, like internet forums like Reddit, Twitter, Facebook probably not, because that's not openly accessible, but yeah, you get the idea. And this is a very interesting chart. Basically, ChatGPT is the fastest growing technology of all time. Yeah, you can see here, Instagram took them 30 months to reach the first 100 million users. ChatGPT did it in just 2 months. And I mean, by now this slide is already outdated. They could probably update this, reaching the first 1 billion users, and ChatGPT will also have a ridiculously small amount of months in that chart, right? So we can see that they seem to have discovered something that people really like to use, and that spreads like wildfire. Okay, so here's the paper that I've mentioned in 2017, Attention is All You Need. This is basically a new architecture for these kind of neural networks that's called the transformer model. And this allowed these breakthroughs that we are now seeing with these GPT models. Yeah? Before the transformer model, there were all kinds of other neural networks that also produced very impressive results. But I think the transformer model, for once, the parallelization is easier. So you can train it with much larger amounts of data in a shorter amount of time, and you need less GPU power to do it. But also there are some very smart things that teach the model about the positions of the words in a sentence. Other models didn't really do that, but this transformer model understands that certain sentences that have basically the same words, but some words are in different positions, that gives the sentence a completely different meaning. And this transformer model can understand this kind of semantics. So I was talking about 1 trillion parameters just now. On a very, very, very simplistic level, you can think of these AI models like this. We want to create a mathematical function via brute force, basically. We want to put some value x into that function, and the function should predict some value y and give that back to us. This is like what all mathematical functions basically do, right? In when we talk about language models, this X is a sentence. It's like what you type into the ChatGPT window, that is your X value. And what ChatGPT replies to you, that is the predicted Y value. In reality, what it really does is it takes your text and it predicts just the next word. And then it takes your text and that first word, and then it predicts the second next word. So that's why when you talk to ChatGPT, you can see the words coming up one by one, because that's literally what's happening behind the scenes, right? Each time it calculates the next word based on all the words that you can currently see on the screen. You know? So, and I mean, you could think of this function as something like that. That's probably very simplistic and probably very wrong, but that's how I like to think about it. We have our function here, we throw in X, and then inside the function, there are all these unknown variables, A, B, C, D, E, F, G, right? And we multiply them with X. And so these are the parameters. Now you have to imagine this is a function that has 1 trillion parameters, right? And we are trying via brute force, via buying 20,000 GPUs that each cost, I don't know, like $20,000 probably, and letting them run for God knows how long, maybe 6 months or so, which is why this thing cost $100 million to train, right? They had a ridiculous amount of GPUs and they let them running for a long, long time so that it can read the entire internet, and then it starts to learn. And as it learns, it tweaks all these A, B, C, D values until it has found some values that produce overall good results for whatever X we throw into it, right? Okay. Also, very, very high level. How does this thing train? Basically, you have to think about this is our input, and these words, we will from now on not call them words anymore. We will call them tokens, and I will describe that in a second as well. These tokens are turned into some kind of numerical thing, because computers can't understand English language. They can only do math with numbers. So we need to turn the words into numbers. And then we pass these numbers through this transformer model, and it will predict whatever. In the very beginning, when it just started learning, it's going to predict ridiculous nonsense that makes no sense at all, right? So of course, when we say may the force be, what's going to be the next word? May the force be with you, right? So the most likely next word is probably with. So the model will predict something very wrong. We will then tell it, no, that was wrong. This is the actual word that we want. And then there's some fancy math that you can do to calculate. It's called a loss function, to calculate the difference between the value that we got and the value that we wanted. And this difference can then be used to do something that is called backpropagation, where at all kinds of steps here in the model, there are these 1 trillion little variables that we try to these 1 trillion parameters that we try to get to the right values, right? And during this backpropagation process, each of these 1 trillion parameters gets tweaked a tiny little bit. And then hopefully next time when we ask ChatGPT something, it's going to predict something better. And we keep doing this over and over again for like terabytes of data, probably even petabytes by now, until, just by seeing all these English sentences and always getting it wrong and then getting it right eventually, it's going to learn something about the world and about the English language, and all languages actually, and it will eventually be able to predict the next word in a very likely manner, right? Okay, let's talk a little bit more about this concept of tokens. So another thing that, if you want to go deeper into this, that you can look at is an algorithm called BPE, byte pair encoding. This is what's generally used to turn a dictionary of English words into a dictionary of tokens. Let's assume we had a dictionary of only 3 words: astrology, astronomist, and astronomy. And this algorithm would basically, figure out that, oh, astro seems, the syllable astro seems to be appearing very often. So let's turn this into a token. Then no seems to be appearing very often. Let's turn that into a token. And then all the rest doesn't seem to be related in any way. So let's just take those as tokens as well. You can see in this stupid example here, it's kind of not very good, because now our original dictionary that only had 3 words now turned into a dictionary that has 5 words. But if you imagine, if we turn the entire English language into Lego pieces like this, you can, with very few Lego pieces, you can create every English word, right? So you can imagine when we take like 60,000 English words or something, that the actual dictionary of tokens is going to be much smaller. And that's important because as we are training the AI, we are trying to attach a meaning to every single token. Oh, by the way, I wanted to show something here as well. So we'll probably come back to the site later again. So OpenAI actually has this tokenizer playground here where we can throw some text in here. Yeah, and now with a microphone in my hand, this is pretty difficult. Okay, like this. And then you can see here, this is how this paragraph of text got tokenized into tokens. Every colorful blob here is one token. And you can see there are really unintuitive things as well, like just space and capital G is also considered to be one token here, right? So it creates a large variety of tokens. It can even have sometimes the with a capital T and the with a lowercase t. Those are considered two different pieces of vocabulary in our total token vocabulary, right? All right. So what these large language models eventually do is they attach a vector to every single word or token in the vocabulary, okay? And in the case of the text embedding ADA002 model, which is the one that OpenAI recommends everybody should be using for turning tokens into vectors, that's also described here on their website. Here they describe here what kinds of embedding models they used to have, and then there's this second generation model here, and that's the one that we should be using. It's the cheapest and fastest one. And so this is basically a vector of 1,536 dimensions, right? Every token you can imagine is a vector with 1,500 numbers in it. Yeah? And while this model was training for $100 million, 6 months on 20,000 GPUs, it figured out these numbers in these vectors over here, okay? And this is where all the magic happens. If we look at just one of these vectors, the crazy thing about these vectors is, and that's when people say, oh, AI is like a black box. We don't even know how it works, right? But what they mean is, what the scientists mean is, we don't know what each dimension in the vector actually represents. It could be maybe that the first dimension out of 1,500 dimensions has something to do with color. So whatever number is in that first dimension seems to be encoding maybe a color or something, right? Another dimension might be meaning something about gender or about size of things or anything. Maybe there is, who knows, maybe there is one dimension that is about do I feel like wiping out all of humanity? And if the value gets very big, maybe the AI is going to turn against us. Nobody knows what these dimensions actually mean, and that is that is something that scientists want to figure out. If we can somehow debug these models in some way so that we understand what it has learned about the world by decoding what these numbers actually mean or what they refer to, we could learn a lot about our own worlds as well. And so I love this. Let's assume we had only three-dimensional vectors, right? You have a three-dimensional space here. And let's say the token king got encoded in this way, the token man got encoded in this way, the token woman got encoded in this way. So one thing that already sticks out is if the model has learned well, the vectors should be in such a way that things that are similar to each other are close to each other. So you can see gender-related things seem to be in one region here, but like apple has nothing to do with man and woman, is far away from these human things, right? Or like animal things are also pointing in another direction than human things. And an even more unbelievable thing is the vectors are such that if we take the vector of king and we subtract the vector of man and then we add the vector of woman, we arrive somewhere very close to what the vector of queen is. So if the model has learned about our world very well, the vectors are in such a way that we can do this kind of math. King minus man plus woman equals queen. Yeah, to us, when we see that, it makes sense, right? How a machine can come up with this, I feel, is kind of mind-blowing, right? So, and once again, we can then play around with these vectors, do kinds of crazy little math and see what it comes out with that can also derive, it can also tell us about, give us new insights about our world that might be unintuitive, that we might not have considered before. Okay, so this is just a super high level overview of how these large language models work under the hood. I gave you a lot of vocabulary that you might want to dive deeper into, like LLMs, tokens, byte pair encoding, vectors, right? And I watched basically all these YouTube playlists in order to know what to say to you right now. So if you have 10 hours of time, you might just watch all these videos, and then you can give a talk like this as well. And these videos are all really amazing, very well animated. So I think learning about these things without visual animations is very hard. If you read a scientific paper and you're not very good with vector math and all that, you have no chance, right? But if you see it animated in a YouTube video, it's actually pretty easy to understand. Okay, let's get into the actual meat of the talk and do some coding. So my point of the talk today is to kind of convince you that you should not ignore this, especially not if you are working as a programmer. It will, like many people, when you read about it online, they kind of dismiss it. There are basically two religions now. The one half says, man, this is amazing. It makes me so much faster and so much more productive. And the other half says, yeah, I tried it, but most of the results aren't really correct. Now, of course, it's not 100% correct, but you will see later what it outputs is still quite amazing. And if you only have to change a few characters here and there to make it correct, it's still worth the time, right? So one technology that I will demonstrate is called GitHub Copilot. So you can go to their website and you can sign up for a plan. I made my company sign up for myself. So now when I use Visual Studio, the first time I have to install the GitHub Copilot plugin for Visual Studio, and then it will authenticate itself against my GitHub account. And from then on, there's going to be a little, I will show you later, a little GitHub cat at the bottom of my editor, and whenever it's thinking, it's going to spin, and then I just wait for it to stop spinning, and it usually will present me with some code that I'm most likely going to type anyways. That's the point of a large language model, right? It sees what text is there, and it predicts what text should follow, right? And then we will talk about OpenAI, of course, ChatGPT, right? So if you wanted to build what I'm building now, you would need API access to OpenAI. So you would create an account here. And then once you have created your account, and of course, given your credit card, you can then create API keys. I will do this in a second as well. But you, of course, have to be aware. Every time you send a request to OpenAI and let ChatGPT predict something, it's going to cost some money. You can see here, I'm already addicted to this. So I spent $14 last month summarizing YouTube videos, right? That's what I'm going to show you today. Yeah, this seems to be the new world that we are in. We got to cancel our Netflix subscriptions and Disney Plus and all that so that we can afford talking to the AI and so that the AI can tell us interesting things. Okay, and that's a bit confusing. It's the same company, OpenAI, but you need to pay money in order to use the API. But here you only pay for what you use. And then you can also pay money for ChatGPT, which is that web interface that most of you have probably already seen. And if you pay $20 per month for that, you get access to ChatGPT Plus, which looks like this. So most people who don't pay, they can only use GPT 3.5, which is by far not as smart as GPT-4. And if you pay, then you get access to GPT-4, and then there's even a plugin marketplace now. I haven't started playing around with that, and it's already exploding. There are already hundreds of plugins. Yeah, so that's that. So what are we going to build today? What's the time? Okay, great. We will make a tool that can summarize YouTube videos, okay? This tool will do the following things. First, it downloads the audio of that YouTube video. Then it uses another AI model called Whisper, which is also from OpenAI, to turn the audio into text. That alone, I already think is mind-blowing. And the accuracy is absolutely incredible. Even with people who don't speak English very well, have accents or whatever, this thing always gets it right. It's crazy. Then we will split this text into smaller chunks. Keep that word in mind, chunks. I'm going to talk about chunks a lot later. And then we will send each chunk to OpenAI, and we will say, please create a concise summary of this chunk and give me only the main, the main arguments of this text as bullet points. That's going to be our prompt, and then one chunk. And then for very large text, this is where the context window comes in. I mentioned GPT only has 8,000 or 32,000 tokens. Wow, what happened? Oh, this is a, oh, nice. Okay. Test. All right. Does this work? What's the volume? Test. Okay. I think this works, right? All right. So I mentioned that. Oh, this is actually not very useful. Test. Okay. I mentioned that the GPT-4 model has 8,000 or 32,000 tokens, and the model that I'm using with the API actually only has 4,000 tokens. That's an even faster and cheaper model. So that means our prompt plus the chunk of text plus the response needs to fit into 4,000 tokens, right? And if the YouTube video is very long, that's going to be more than 4,000 tokens already. I need to chunk it into smaller chunks and then send it to OpenAI and ask for a summary for each chunk. Okay? All right. On the computer, it will look like this. On the terminal, we will be typing Python, GPT summarize, YouTube, and then the link. And then it's going to download that audio file. Then in the next step, we will say Python summarize, transcribe this file, and then we will see the text coming up as it is transcribing it. And then finally, the third mini program that we will build is we will say Python summarize this transcript that I've just created in the step before, and then it will send this to OpenAI, and it will come back with the actual summary. Okay? All right. So let's start, right? In order to make a new Python project, what I always do first is I create a folder for my project, okay? And I do these things on a terminal. You might be doing it with Windows Explorer or your MacBook Finder, but it's faster to do these things on the terminal. So mkdir means make directory, and in my home folder, I will put a projects folder, and inside that projects folder, I'll put a GPT summarize folder, and inside that GPT summarize folder, I'll put another GPT summarize folder. You don't really have to understand right now why I'm doing that. So let's go into this new folder that I've just created. So we can see it's empty except for the other GPT summarize folder that's already in there, right? Okay, so yeah, we go into that. So now I have to create a bunch of files, and we will see what all of these files do later in the talk. So let me just really quickly create them. So the touch command basically creates an empty file if the file doesn't exist yet. If the file does exist, it doesn't do anything. Okay. And lastly, I also need to create a few folders already. So the first script is going to dump the audio file into a subfolder called files/audio. And the second script that we will build is going to put a text file into files/transcripts. And then the final script that we will build is going to put the summary as a text file also into files/summaries, okay? So there's a cool command here called tree. And so if you have done everything correctly, then on your computer, when you run tree, it should look like this, right? In the root, we have a hidden file called gitignore and a file called requirements.txt. There's a folder with 3 subfolders. And then in this folder, there are a bunch of Python files, which are currently all empty, okay? All right, let's start with the gitignore file. Usually you put things into the gitignore file that contain secrets or that contain stuff that your program generates, but it's not really part of your program, of the actual programming code, right? So I will start Visual Studio now, and I will open the gitignore file. And then I'm going to put this code in here. So I usually put my secrets, and the secret that we will need today is the OpenAI API key. I will put these into a file called local settings. And this file should never be shared with the rest of the world. So that's why I put this into the git ignore file. Also, see down here, this little, what is this? It's probably an octocat from GitHub, right? Or is it a mouse or something? Or it's the octocat with pilot goggles, probably, right? Because it's a Copilot. So anyways, this thing now observes every file that I open in my IDE and sends them to GitHub. So you wouldn't want to open files with secrets inside, because this thing is immediately going to send it to GitHub, trying to predict what you want to do with that data. They, of course, promise that they will never share your files with anyone else, and it's like all sandbox and super secure and all that. And I mean, yeah, what can we do? We have to trust them. But you really want to be sure and not and make sure that it ignores certain files. So files that are named here in git ignore, when I open those files, this little spy down here is not going to do anything. It's not going to look at it. At least that's what they promise, okay? All right. So, okay, so now we will put our actual API key into the local settings file over here. And of course, I need to create one. So let me go to OpenAI, login, API, personal, API keys, create new key. Let's call it whatever. And there it is. And now we have to put that in here. And now you've all seen it, and it's on video. So please don't go home and use my key to spend my money for your ChatGPT summaries, okay? Now, of course, after this talk, I'm going to delete this key. So now we have that key in our local settings file. And finally, as preparations, I already know that we will need to install a few things, a few Python libraries. And in order to install things with Python, right, you usually do this pip install and then the name of the package. And let me do something here that I'm not going to explain. Just forget that you've seen this. So normally I do like pip install requests, for example. And then this package will be downloaded and be installed. And from then on, I can use that package in my Python code. And a better way is to keep note of all the things that you have installed and the specific versions that you have used, and put them into this requirements text file. And then we can simply do pip install -r requirements text. And I mean, it's so fast now because I've already installed this before, but then it would start downloading everything, and it's going to take a while and install everything that is needed. Yeah. Okay. So let's start coding. So in the first file, source YouTube, let's put some starter code. So this is how I always start my programs. Yeah? If name equals main, I want to do something. Usually I will put some main function here. I want to download audio. That is the thing that I want to do. I'm doing some other magical things here. So those of you, I mean, many of you haven't done Python before, so I will take some time to explain this. Okay, this is very difficult to explain for someone who has never done Python, but basically, in every Python file, there is a magical variable called __name __. That's just there. You can use it. And the value of this variable is a string, so some text. So I can compare this variable to whatever text I like. And the thing is, if you start this file from your terminal, so this is your main program, then the value of this name variable will be __main __. Okay. However, if another Python program maybe imports the download audio function that we will build later, so we are not actually starting this file, but maybe some other file that just by coincidence uses something from this file, then the value of this variable will be something else. It's not going to be __main. Okay. So this gives us the ability to say, we only want this code down here to run if we are running this file as our main program from the command line. Okay, so for those of you who have never done Python programming, it's not super important to remember this, but I mean, now at least you have heard about it. And then, so sys is a module that belongs to the Python programming language, and it has a magical variable called argv inside itself. So I can import the entire sys module, and then I can have access to this argv variable. And this argv variable is actually a list of values. And the first item in the list, so the item with index 0, is the name of this file. And the next and next and next and next items, however many there are whatever we have written on the command line. So later we will run this program like this, right? Python, and then we go into the GPT summarize folder, and then we call the source YouTube module. And we will have to provide the URL of the video that we want to download, right? This is the first argument. And you can write Python programs where you might be putting in a lot of different things on the terminal to pass these information into your programs, okay? And the sys module is how we get access to these values that were provided on the terminal, yeah? So basically, the second element in this list is going to be the YouTube URL video that we want to download and summarize, okay? So we will store this in a variable called URL. Yeah, and then we want to throw this URL into some download audio function that we have to build ourselves. And this function shall return the path to the file, to the audio file that it has just downloaded, so that we can then just print the path to that file. And then we can copy and paste that path into the second program that we are going to build after this, okay? All right, so see, this is how you would start a simple Python program. You haven't even done any coding yet. You just wrote some boilerplate to make up your mind about what kind of work your program is going to do and how you're going to name your functions, right? So that's the first step. If we would run this now, this would crash because there is no function called download audio and no variable called download audio, right? So this would currently crash. So the next step would be to create just some dummy code where we just don't do anything. We just return some random text. So then we could run our program on the command line and see if so far we haven't done any mistakes and it is working. Yeah? So you can see you can inch forward to your final goal by making these kinds of baby steps in your programs. We haven't done anything intellectual so far. We have just written down boilerplate, right? And at every step, you save your file, you run it on the terminal, you see if you made any syntax errors, and then you fix them straight away, right? But here, before actually putting this this dummy text code here, let me show you now what GitHub Copilot can do for us. If I just type def, now you can see it's thinking down here, and it knows. Down here, I'm using a function download audio. The function doesn't exist yet, so most likely I will want to create a function called download audio, and it should suggest that to me already. You might probably want to make a function called download audio. So I just have to press tab, and it comes. It appears, right? And it has already seen that we are passing in one parameter, the URL, so it already puts one parameter in the function definition as well and names it URL, okay? So now when I press enter, it's going to think again, and this is quite mind-blowing. Okay, when I tested this earlier, I did something else. Now it does what I actually wanted to do even. It creates a doc string first, right? It describes what this function is supposed to do, and that's a very good way. In the future, we will not do programming anymore. We will just type in English words what we want the computer to do, and just write it, and then the computer is going to do the coding for us. And let's see if that actually works, right? So when it doesn't suggest a doc string already, I get it to do like this, right? I type the 3 quotation marks like this and press enter. I put the cursor here and press enter, and it's thinking, and it's providing me with a doc string, right? It downloads audio from YouTube video. I think the English here is a bit bad, so let's fix that. Downloads audio from a YouTube video. Also, in my company, we are very specific about describing all our functions. So, and see, if I put the cursor here, it realizes, the guy wants more doc string. Maybe, and some companies do it in this way, but I'm doing it differently. I'm saying the URL parameter means YouTube video URL. Actually, that's also not really how I like to do it. I like to say it's a string representing a YouTube video URL. Okay, right? So that's nice. And now it has learned, this is how these people do the documentation. And it came up with, they most likely also want to describe the return value of this function. I actually like to name this returns and not return. And it correctly says the path to the downloaded audio file, right? And it learned this from down here because this variable is called audio path. So it already understood, and I guess it would have guessed this anyways, because that kind of makes sense for this kind of function to do that. So it came up with all this, right? You could have just written this very quickly without waiting for it, of course, and just describe in English terms what you are trying to do, what the function gets, what the function produces. Now that it has all this code, when I press the cursor here and press enter, and it will think for a while. Oh, and that's the demo effect. Now it's too lazy to come up with proper code. That's such a shame. Okay, when I tried this earlier, it actually implemented the entire function. Let's see if I can somehow, how can we make it do what I want? Maybe implement function here. No, it's lazy today. I have no idea why. Okay, but that's okay. We just want to put some demo code here. It's going to be in files, audio, test.mp3. Okay. At this stage, we have made up our mind how our program is structured. We haven't written any real code yet. It might now be a good idea to see if we are able to call the program. Yeah, so correct. No crashes. It returns this hard-coded text that I have put into the function anyways. So we are good, right? So what do we do if Copilot is striking as on a labor strike seemingly and refuses to do its job and refuses to code the function for us? We still have its big brother ChatGPT, of course, right? And this is the second thing that I want to pitch to you today. Copilot is quite nice, but Copilot works better if there's already a lot of code in your file. It can see all the code, it understands your programming patterns, your best practices, and it then suggests new code that you most likely are trying to build. It can look at all the other files on your disk and that you currently have open, and it's quite amazing. But of course, sometimes when you're starting from scratch and there's no code at all, it might not know what it's supposed to do. Then we can go and ask Big Brother ChatGPT. We could ask something like, hey, how can I download the audio of a YouTube video with the YTDLP library in Python, okay? And it will produce something like this. It will explain to you how to install. I have only given the bottom of the response. The first step was pip install YTDLP, and then it says you can import these things, and you could write a function that looks something like this. All right. Let's just try that, right? So I gotta add this import to my code. And I gotta add this to my code. Okay. So I will not run this now, but when I tried this, it worked. So it worked on the first try. And by the way, if you go to the README file of the YTDLP library, it's a horrible mess. I could not find out how to use it in Python because it's also a command line tool. So they wrote a gigantic README file about all the things you can do on the command line, but not a single line of how to use this in Python. Okay, so this actually saved my day, right? I would have given up. If I just see the README and I don't see any Python examples, I would have dismissed this library and not solved my problem, right? But ChatGPT knows how to use this, luckily. But I realize that how do I get the file name? I want to return the audio file name at the end of my function. And the way this is coded here, it doesn't return the file name at all. It just puts the file on my disk, but I don't know what's the name of the file, okay? So, of course, we don't need to despair. We can just ask a follow-up question in the same chat with ChatGPT and say, how can I retrieve the file name? And then it comes up with some pretty messy code, but it actually works. So I tidied it up a little bit. So what we are going to do is we are going to put some variable here that we will fill later. We have to put a function into our function. So we are inside the download audio function, right? We put another function here called getFileName, and need to import the OS module. And then here's the trick. This YouTube download library has something called progress hooks, okay? So we can put that down here into the settings. And what it does is, while it's downloading the audio, it's constantly calling whatever function I put here into the progress hooks. And then we are able, for example, to render a progress bar on our screen. Or, eventually, this function will get called with a dictionary. And this dictionary contains all kinds of information about the currently ongoing YouTube download. And at the very end, this dictionary contains a key called status, which will have the value finished. And when we have reached that value, then it also contains a key called file name, which is the file name that it has generated at the end. Okay, so that's how we can extract the file name. And then I'm doing some little tricks here because I just want to get the file name and not the full system path. It's going to be like my name / projects / GPT summary and so on. I want only the file name that it has created, right? So I'm stripping away a few things here. And then I'm storing that file name in my dictionary variable that's outside of this function. It's a bit of a hack. It's pretty dirty programming. We are not supposed to do this, but I couldn't find a better way to do it. So now, after YouTube has done its downloading down here, right? We know here it's going to download. While it's downloading, it's constantly going to call this function. This function is constantly going to check if the status of the download is finished. Once it's finished, we are storing the file name into this variable here, which we can now access down here again, and then we have our file name, and we can return the file name. By the way, there is a better way of doing this, but ChatGPT didn't tell me about it, and I was too lazy to figure it out. When I tested this earlier and Copilot gave me the whole code, there's actually a better way to simply get the file name right after the download, and you don't have to do this weird progress hooks thing. But I found it interesting to learn about the progress hooks anyway. So yeah, why not? We can do it this way. This works, okay? Now we can see if this actually works. So let's see. And I hope this works. Yeah, it works. So, okay, I chose a very short 5-minute video of Sundar Pichai talking about AI. And if everything worked, we should now have an audio file in our audio folder.
AI is probably the most important thing humanity has ever worked on. Now, I think of it as something more profound than electricity or fire. And anytime you work with technology, you need to learn to harness the benefits and while minimizing the downsides. Stepping back, when you think about...
Okay. And I played the few seconds now because later when we do the transcript, you will remember what you just heard, and you will see it's very, very accurate, okay? So that was the first step of our little tool chain that we are going to build, right? The second step is we want to transcribe this audio into text. And once again, we will start with some boilerplate code. So I made a new module here that says do transcribe. And I'm doing always the same thing. I'm always starting with name equals main, so that even, in reality, when I build modules, there are going to be just functions in there. And then my main program is going to import these functions and do stuff with it. But while I am building these functions, it might often be quite useful that I'm able to call these functions from the command line so that I can continuously test and see if the functions return the things that I want them to return, right? So always having this code at the bottom of your file and then, calling the things that you are building inside the file is a pretty good way to, iteratively progress towards the end goal of your bigger program. Yeah. So once again, here we say there's going to be some value that we provide on the command line, and that is the file name of the audio file, right? In the last program, it was the YouTube video name, the URL, and now we are providing the file name of the audio file that we have just created. Okay. You can see here when it's done. Oh, actually not. I did not output the file name. Oh no, it's probably this, right? This is the file name. So we are going to call the next program like this, right? We will say do summarize and then the file name. It's a very, very long file name. It would be better. And actually for myself, I have already improved this program so that the file names are much shorter and, no spaces and all that. But for this demonstration, these ugly file names are fine. So in sysargv1, it's going to be the audio file name. we will build a function called transcribe. The function will get the audio file name, and it should spit out the text file name of the text file that it has generated that contains the transcript, okay? And then once again, we can do the same magic as before. It has already understood that I'm most likely going to build a transcribe function. I see, transcribes an audio file to text. That's exactly what it does. It has learned from the other file that this is how I want to document my arguments, right? So audio path to an audio file. Actually, this will be better as string representing a path to an audio file. At some point, it's going to learn that, and then maybe next time we will be more lucky in the final file. And it knows returns path to the text file containing the transcript. Very nice. Is it able to figure this out? Probably not, because it doesn't know what AI model we are going to use. Yeah, it's thinking very long, and oh, interesting. It seems to use some model called deep speech that I've never heard before. So I could have now gone off to Google and learned about deep speech. So that seems to be another way of transcribing audio files. But of course, we are trying to do this in a slightly different way. So for now, I'm just returning files, transcript, and it already comes up with a nice placeholder text here. So now I can test. I can test if so far there are no typos and syntax errors. Do transcribe. It doesn't crash. It returns the placeholder text that I've put there. Okay, so the program is working, but of course it's not doing anything so far. So I already knew that OpenAI has this module called Whisper. And if you just read the README file here, they tell you that you need to do pip install Whisper, and then you also need to install FFmpeg on your computer, so they tell you how to do that. And you need to install setup tools Rust. That's already in our requirements text file from the very beginning, so I already did that. And then they describe that this model has different sizes. So if we want to use the large one, we need to download 1 GB. I'm using the base one, which is only 74 megabytes. Okay. And then they tell you, in order to use this, it's probably pretty small. Let's make it bigger. In order to use this in Python, all you need to do is this. Yeah. So you import Whisper, you load the base model. The first time you do this, it's magically downloading the 74 megabytes and putting it somewhere on your computer. I don't even know where. And then from then on, it's always going to be super fast. And then we call transcribe some kind of MP3 file that we have to provide. And it's going to give us the result. And that's going to be a dictionary. And inside that dictionary is a key called text. That is the actual text of the whole transcript. Okay. So for here, I didn't even need to ask ChatGPT how to do this, because the README here is very nice, and I can basically just copy and paste from here, right? So our transcribe function is going to look like this. Yeah, so I already imported Whisper. We will load. Oh, I'm even using the small model. I forgot about that. Even the small model, which is just 13. Okay, okay, base. Small is larger than base, 244 megabytes. That model is relatively fast. So a 1-hour video will take 15 minutes to transcribe. Yeah? So the larger the models get, the slower they get. So like this large model here basically takes real time. A 1-hour video takes 1 hour to transcribe, but I guess it's going to be able to, get all kinds of English accents right. Acronyms is going to be much better at that. Names, usually when people talk to each other and they call themselves by their surnames or whatever, there are always going to be typos in there, because how do you know how to spell a name? Right? If you call a call center and they ask you what's your name, usually you have to spell it, because even humans don't know how to write names correctly, right? But anyway, so we basically just do what the OpenAI Whisper README told us to do. And then here's some Python code to just save that text into a file in Python. I think that's it. Let's just try and see if it works. This is actually, oh, and yeah, here's another thing. If you are a beginner in Python, and I mean, this is I think this is probably where large language models and things like ChatGPT will have the biggest impact on society. Basically, this thing makes schools irrelevant. This thing is an all-knowing teacher. It knows everything about, chemistry, biology, physics, math, statistics, you name it, programming, especially programming, right? So if you are a beginner in Python and, you follow my slides, when I'm telling you all these things, it seems all very easy and intuitive, but if you try this at home, you will see lots of code and be like, what the hell does this actually do, right? You can simply ask ChatGPT, okay? So, for example, when we have this line of code here, file name equals os pass split text of os pass base name for audio pass bracket 0. What the hell does this mean? One long line of code, right? You can simply ask ChatGPT and it will then break it down into step-by-step instructions, right? And it knows that in order to understand such lines of code, this is this line of code here, you have to, this is basically a function call inside a function call. I'm doing it on one line of code. I could have split this into several lines to make it easier to understand, but sometimes programmers are lazy and they just write it as one line of code. So we are calling the base name function with our audio pass, and this returns some output. And that output we will put into the split text function, and this returns some other output, which is going to be a list. And from that list, we are taking the first item. So this is how you have to read this. If you are professional programmer, you know how to read this very, very easily. If you are a beginner, you will look at this line of code and have no idea what the hell is going on, right? You can simply ask ChatGPT and it's going to explain it to you. And if that's still not good enough, you can say, okay, regarding step 1, can you explain this like I'm 5? Like it can even do these things, but it seems to think that 5-year-olds are very, very smart. Whenever I ask it to explain it like I'm 5, it's still pretty high level, in my opinion. But yeah, you can, converse with this thing and treat it as your programming mentor. Okay, yeah, let's see if this works. So let's see. So it's loading up the Whisper model. It loads the 200 megabytes into RAM, and here it's coming up already. You can see it did 20 seconds in one go, now 50 seconds already, so it's pretty fast, right? And it's exactly the text that we've listened to just a few minutes ago. And it's talking about, we have to talk about safety, we need to be transparent about the risks. We, it can be a risk about cybersecurity. It can be used for military purposes, which we, as a society globally need to come to a conclusion to not use this for military purposes. Of course, that's not going to happen. We will definitely use this for military purposes, but whatever. Okay, so here's the next step. Now we have already finished the first 2 tasks out of the 4, which is downloading the audio and transcribing it into text. Oh, by the way, let's have a look at the text file. So here under transcripts, there's now a text file which contains the entire text in one long line of code, of text, right? So there's the text. Okay, now we have to chunk up this text into smaller pieces, whereas this is so short it probably fits into one chunk. And then we have to send these chunks one by one to OpenAI to give us a summary. This is the slightly more involved part of and the final part of what we want to do today, okay? So once again, I made a new module called do summarize. And once again, I always start with this name underscore main thing. By now, this is boring to you all, right? You have seen this already. And once again, I am providing something on the terminal. And this time, I'm providing the path to the text file that contains the transcription, right? In the program before, we provided the audio file name. And in the first program, we provided the YouTube URL, right? And in this one, we are providing the transcript file name. And what are we going to do? We want to make a function called getSentences. So we want to split up this text into just the sentences, into a list of English sentences. Then we want to create chunks. We want to group as many sentences as we can to squeeze them into the 4,000 token window that we have available. And if there are some, if there are so many sentences that they don't fit into 4,000 tokens, then we will make a cut here. And then we will take the remaining sentences and put them into another chunk, okay? And then finalize. Once we have the chunks, we will call the summarize function, give it all the chunks, and yeah, it's going to send each chunk to OpenAI and ask for a summary. This is what we're trying to do, okay? And yeah, once again, oh yeah, before we get into the meat of it, I will provide some variables here. Here I am importing the OpenAI API key that I have generated just now, and we put that into my secrets file down here, into the local settings file, right? This is going to be our prompt. We will say, create a bullet point summary of the following text. Make sure that all major talking points are part of the summary, and use dash space for the bullet points. When I tried this very first time, it got confused. Sometimes it used dash, sometimes with a space, sometimes with no space, sometimes it used asterisks, right? And it looked quite ugly. So if you tell it, please always use the same for the bullet points, the output just looks a little bit nicer. Of course, we are sacrificing a few tokens here to give it an instruction that now are no longer there for the space of the actual text that we wanted to summarize. And then here, so in Python, this is going to be a variable. I will later insert all the sentences that fit into one chunk at this location here, where this chunk placeholder is, okay? So we are not literally sending this to OpenAI. You have to imagine where you can see the chunk placeholder right now, there are going to be a lot of sentences from our transcript, right? So then OpenAI can see the text, and then it's going to summarize the text, yeah? Yeah, here I have some constants, which model I'm going to use, what kind of encoding, I will explain this in a second. What are the maximum tokens that model can handle? And this is, actually I'm not using this today, but for myself, I also want to calculate every time I use this program, I want to see how much money I'm burning so that I don't get too excited and don't, you know, transcribe 200 YouTube videos and it suddenly cost me $100 or something, right? It costs, actually this is a typo, it costs 2 cents per 1,000 tokens to talk to ChatGPT, yeah? Okay. As usual, we would first fill in dummy code so that our program doesn't crash anymore. You can see here, right? It's complaining that these 3 functions don't actually exist. So I make them available. And at this stage, we should be able to run the program. Yeah. And you should always do it that way, just to make sure that there are no stupid syntax errors at the very beginning, right? So otherwise, once you start filling all this with actual code, and then you run it at the very end, there will be lots of errors, and you have no idea at what point you introduce those errors. So better run the program often, and so that the errors are still simple and easy to fix for you, okay? And you know, you get the idea, right? I could, you know, ask ChatGPT, or rather Copilot, to come up with, nice explanations here. It's really quite incredible to see this. Chunks from these sentences, correct. And then what is this thing gonna do? Returns a path to the summary file. Yep, also correct, right? And there's still one thing missing. Okay, let's get to that later. Working with tokens. There's a very nice article here, so it's linked in the slides, right? Where you can understand a little bit more about tokens. I have already shown you this thing with the byte pair encoding, where we try to turn all the English words into another dictionary of tokens. So it's kind of described here. So basically what you have to understand is that not one word is one token. It's more like 100 tokens represent 75 words, okay? And there's also, there's not a link here to the, no, there's no link here to the playground that I showed you earlier. But you can just Google for OpenAI token playground, and then you get to that. You get to see that playground again. Yeah. So there's another library published by OpenAI called TickToken, which allows us in Python to count how many tokens does this text have. And this is quite important for us right now, because we have English sentences, and we are trying to squeeze them into a chunk of 44,000 tokens. But how do I know how many tokens this English text actually is, right? And so this TickToken library allows me to count an English text, and it's going to tell me how many tokens that represents. And so the README here is pretty good, so I don't even have to ask ChatGPT how to use it. So we will use code from this README for this. And when you deal with OpenAI, you will want to read their documentation, and then you want to learn about what kind of models they have. Yeah, so the GPT 3.5 model is the one that I'm using, because currently I don't have access to the GPT-4 model with 8,000 tokens. As soon as I have, I will use that, which will make me even poorer, because then my summaries will be better, but they also cost more. But the 3.5 model is actually really damn good already. And there are certain model names that they have, and they have different properties. Like they have, so for example, the Code DaVinci is, I think that's probably the one that GitHub Copilot is using under the hood. And it needs to have a large context window so that it can see all the code in my file, right? Whereas all the, chat models, they don't have such large token windows, because usually you don't type that much when you talk to these models, right? And they also don't have to respond with that much text. So 4,000 tokens seem to be enough. So let's do a little bit of math gymnastics here to figure out how we need to use our token space wisely, okay? So I showed you already that this is the chunk that we have. I used the tick token library, and this library told me that this text here is 37 tokens. So out of the 4,000 tokens that I have, 37 are already gone for the prompt, okay? And I want to allow ChatGPT to give me a summary that contains 1,000 tokens. I don't want it to ramble on forever. And after all, I'm telling it to give me a concise summary. So I felt 1,000 tokens, roughly 700 words, is quite a lot. So I could probably even tweak this. I feel like the summaries are never really more than maybe 400 words. Then I would have more space to give it sentences for the actual chunks, right? So that means our chunks can be 3,060 tokens, right? 37 tokens for the prompt, 1,000 tokens for the response, for the actual summary. That leaves us with 3,060 tokens, tokens of text that we can send to ChatGPT to summarize. Okay, so this part here, where the chunk is, this can be up to 3,060 tokens. Okay, all right. So, and there are many ways how you could chunk text. We could simply, for example, go by characters, right? We just say after 3,000 characters, we stop, and then this is the first chunk. But that means we might be splitting words into half, and then the end of the last sentence and the beginning of the sentence in the next chunk are going to be gibberish, right? The ChatGPT will lose understanding of what we are trying to say. So splitting words in half is obviously nonsense. Even just splitting in between words is also nonsense, because then we will split sentences in half, right? So we want to be able to get a list of full sentences, and then we take a full sentence into the chunk, and then we check, is it 3,000 tokens? If there's still more space, we take another full sentence into the chunk. Then we check again, is it now 3,000 tokens? And so on, right? Until the next sentence would exceed the 3,000 tokens. Then we know that this next sentence no longer fits into this chunk. We got to put that into the next chunk already, okay? So that way, the summaries are going to be really high quality, because ChatGPT is going to see full sentences, and so it's usually understanding pretty well what we're trying to summarize. Yep, and so I didn't really know how to use the Spacey library. ChatGPT told me, very easy, import Spacey, load another model. So it's going to download, I don't know, probably 70 megabytes or something. And then we give it the text, and it's going to give us some variable called doc. And that variable has another variable inside called sense, which means sentences. And that is a list of all the sentences, okay? So that means we can implement our get sentences function like this. Yeah? So this function opens up the whole transcript, loads spacey, and then splits the entire text into just its sentences, and then returns the sentences, okay? And once again, if you are new to Python, this line of code will be confusing because this is something called list comprehensions, which is not very noob-friendly. So you could just use your friendly mentor, ChatGPT, and say, please explain this line of code, right? And boom, it's going to explain to you what list comprehensions are. So first of all, it tells you that this is a list comprehension. Like now, if you want to Google more, you know what you have to search for. If you are a total beginner and you see this line of code, you don't know that it's called list comprehension. So this very first sentence already is amazing to help you on your journey to learn something, right? So basically, it describes how list comprehensions work and what it's doing. I'm not going to explain this here right now. It's not so important. And of course, always be friendly to your AI. When the Terminators come along, you should be one of the humans that they like, right? Yeah. Okay. So, right. So at this stage, I realize we actually also need a function called count tokens. And this is where we use the tick token library, right? This is just a little helper function for us that the next function that we are building is going to use. And so we throw in a sentence or any text, and it's going to count how many tokens this text represents, okay? And so for this, I showed this earlier, right? I didn't ask ChatGPT how to do it. I simply looked it up on the README of tick token, yeah? And I guess at some point, I actually did ask ChatGPT, how can I count tokens? And it pointed me towards tick token because it's also made by OpenAI, so ChatGPT is aware of this. All right. And here's another thing. Sometimes, so far, we have just asked ChatGPT, I want to do this, tell me how to do it, right? You can also do something like this, and I do this very often at work. Sometimes your code is very complex, and it might be in a gigantic file that is actually too large for Copilot to fully understand, to fully load into its 8,000 token context window. And so then neither ChatGPT nor Copilot will give you any good suggestions of how to implement it. What you can do is you can describe parts of your code. You only give it as much context as it needs, and then you tell it what you want to achieve. So here I said, I have this code, and then tick, tick, tick. And then here, this is parts of our code, right? This is the prompt at the beginning and some of our constants at the beginning of our file. And this count variable, the count function that we have just implemented. And then I say, please implement a getChunks function that takes an array of strings where each string is an English sentence. It should return an array of chunks. And then I tell it what I want to do with this array of chunks to give it even more understanding of what my end goal is. I say I will use this array to send API calls to OpenAI, and the token limit for those calls is in the variable model max tokens, okay? When generating the chunks, you need to make sure that each chunk is small enough so that I can insert into it the prompt and still have 1,000 tokens for the response left. So that's what when we did the little token mass, right? That's what we already came up with in our minds. And, I could have implemented this somehow myself. It probably would have taken me, I don't know, maybe 3 hours or so, maybe with, some testing and so on. ChatGPT nailed this in the first go. And the crazy thing about this code is, actually, is it on this slide already? Yeah, here. I didn't tell it that I have this, wait, let me go back. Response, right. In my explanation down here, I didn't say that I want to use the variable response tokens, right? I said it needs to be small enough so that there are still 1,000 tokens left for the response. And it somehow understood, the number 1,000 probably corresponds to this variable up here, right? So in the code that it suggested, it actually used that variable, even though I didn't really tell it that it's supposed to use that variable, right? Okay, so thanks, ChatGPT, for doing my work, right? So this would have taken me 3 hours to code on a good day. On a bad day, probably longer. And it took me, I don't know, 3 seconds with 30 seconds with ChatGPT probably. Okay, so let's put that code over here. Yeah, and it even put in comments to describe what these lines are doing so you can understand them better. Yeah? It's really quite amazing. Oops. All right. And so the final step here, and okay, maybe very quickly. What's the time? Oh, okay. No, not very quickly. Let's just take this for granted. So what this code does is, right, it builds up chunks. It starts with an empty chunk. It puts in one sentence, checks if that's bigger than 3,000 tokens. Puts in the next sentence, checks again, does that over and over until it's 3,000 tokens, and the next sentence will be too large. Then it puts that chunk aside and it starts a new chunk. And then it starts filling up all these chunks and it returns a list of chunks to me, okay? All right, so finally, we need to do the actual summarization. And for here, I didn't really ask ChatGPT how to do it. I went to the API reference, and then I learned how to create completions. And basically, the code is here. This is how you use the OpenAI API, right? So let's just take that code. Put that over here. Yeah, so what this does is basically, oops, what this does is, so we imported OpenAI up here, and we will set our API key like this. Then we want to build up a list of summaries, right? Because we assume that the text might be very, very long, so we have to ask OpenAI many times to give us summaries for every single chunk. So all these summaries shall be stored here in this list. Then we say, for each chunk that has been passed into this function here, take our prompt and put the chunk inside. See, prompt was this variable up here, and chunk is this placeholder over here, right? So we are now putting our chunk into that placeholder. So this variable here contains the entire instruction for ChatGPT, okay? Then we ask, we count, okay, because we don't know. These chunks are not exactly 3,060 tokens, right? Because the next sentence might have been very long, and the sentence before might have been very short, so there's some room left. So all these chunks are something less than 3,060 tokens. It's a bit wasteful, unfortunately. But it's still worth it to keeping sentences alive and together, right? So we're gonna calculate how big is this prompt. Then we are saying we wanna use the response shall be the max tokens, which is 4,000 something, minus our prompt. And that will be something slightly more than 1,000 tokens, which is what we wanted, okay? Temperature means it should not try to be creative and should not try to be funny. It should just be very sober and very boring, do exactly what we ask it to do. When you increase this to, I don't know if it's up to 1 or if it's like between 0 and 1, or if it's 1 or larger, you have to try. But I mean, I don't know when I would ever want to increase the temperature. Maybe if you wanted to write poems or whatever. And N1 here is very important. You can actually make this create several ideas simultaneously. But that also costs you 2 and 3 times and 4 times the money. So make sure that you put number 1 here, because if you put a big number here, then it's going to take your prompt and it's going to create 10 responses for which you have to pay for all of them, even if you only like one of them, right? Okay, so then we add those summaries to our list and we save them to a file and we return the file. And this should do the job. So let's see. Do summarize. Okay, it's sending to OpenAI, so it's taking a while because ChatGPT has to think and then it has to write word by word by word, right? And then finally it's coming back to my machine and then I'm storing it into a file. And now in summaries, I have this. So this 5-minute video that, was all this text here, right, has been turned into this. And we remember what he said, right? AI is more important than electricity and fire. Yep, that's exactly what he said. It offers a different construct for solving problems in the world. That's exactly what he said. It can make education more cost-effective. That's exactly what he said. And renewable energy more accessible. It's also what he said. And he said we have to be aware of the downsides. He said that it can be used for surveillance and cybersecurity, create an tyrannical state. And we need a multilateral framework to, prevent that totalitarian state. So that's exactly what he said in that video, right? You can read this in 10 seconds, but it takes you 5 minutes to listen to that video. And it takes you probably 1 minute to read the original transcript, but there's nothing missing. This has everything that was said, okay? So, I've been using this for 2 months now, right? So every time when I summarize something, I put that into my notes. So let's say, for example, here was a video, half an hour, about how ChatGPT is learning how to play Minecraft, and it's actually evolving itself and its own understanding of how to be the best Minecraft player. And I mean, yeah, it's interesting, but I don't have time to listen to a 30-minute video about geeks talking about AI playing Minecraft, right? But there are still interesting things in here. So I'm putting that into my notes. I quickly read them, right? So last month, I summarized 64 videos, which is about 49 hours of YouTube that I would never have the time to actually watch, right? But reading those summaries takes me 10 minutes per day. So I wake up in the morning, I throw in all the interesting videos that I found, summarize everything, and then after lunch, it's done summarizing, put everything into my notes, read it real quick, done, right? So this is an incredible tool if you want to soak up knowledge in whatever domain, especially in, YouTube is nice for things that are actually visual, but there are so many podcasts and videos where just two people talk to each other that have no visuals at all. Why do you need YouTube for that? Text would have been a better medium to convey the knowledge, right? And so this tool allows us to get access to that knowledge at a much larger scale than we would normally be able to, right? So this is the full program, okay? Yeah, and that's basically it. I will be here for a while to answer questions. Okay, thanks everybody for spending your evening geeking out about something like this. And if there are any questions, let's hear them.